Hi, and welcome to Chapter 6, Bonds. In this chapter, we're going to learn about bond terminology, zero coupon bonds, why bond prices change, and corporate bonds. So our learning objectives, we want to understand different bond terminology. We need to compute the price and the yield to maturity of a zero coupon bond. We need to compute the price and yield to maturity of a coupon bond, analyze why bond prices change over time, and know how credit risk affects the expected return from holding a corporate bond. So we're going to look at the risks of different companies. So looking at the bond terminology, this is all review, so we'll just go through this pretty fast. A bond is a security that's sold by government and corporations to help raise money. It's a debt instrument, and what happens is you need to have future payment. So bond certificate includes the terms of the bond. In other words, how long is the maturity, when do they pay the interest, if they pay it at all, etc. And then the amounts and dates of all payments to be made. And then the payments is, this includes the face value and the interest. Some bonds will pay interest every 6 months or once a year or maybe even quarterly. Some of them do not pay interest at all until the very end. We'll get into both of those. The term is the length of the bond. More terminology, the face value is the principal. This is the amount that's due at the maturity date of the bond. So this amount is used to compute the interest payments. So if a bond is a $1,000 bond, and on there it stated the interest is 6%, that's 6% per year, and then it talks about how it is paid. If it's paid semi-annually, then they pay $30 every 6 months, or $60 a year. And then the $1,000, which is the face value, is paid at the end of the term. The coupons are really the interest payments. The coupon rate, I've kind of already alluded to this, the coupon rate is stated on the bond certificate. So it's set by the issuer, it's stated on the bond certificate, it stays the same. Now that doesn't mean the market rate or the actual rate that they are paying stays the same, but on there the amount of actual interest they pay, the cash amount, is stated in an interest rate. So it is an APR, annual percentage rate, and the rate of each coupon, such as if it were 6%, $1,000 bond, then it would pay $60 a year. Or if it were every 6 months, it'd be paying $30 every 6 months. And there's the formula, but it's just the amount of interest paid periodically. On page 147 of your book is a review of the bond terminology. So that's in there. If you have any questions, just let me know, but this is pretty straightforward. So at this point, you can go to the other file that I'm going to have all of the problems worked out, or we will work them out together, but the first one is problem 1. So you can go to that, pause here, and then we'll resume. The next section deals with zero coupon bonds. Zero coupon bonds, there are only 2 cash flows. And the bond's market price is at the time of the purchase, and the bond's face value is at maturity. So what happens is this has no interest. So when you buy these, you buy them at a very deep discount, and then at maturity you get the full value of it, the full face value. Treasury bills are zero coupon bonds that the U.S. government issues with maturities of up to 1 year. And so a 1-year risk-free zero coupon bond with $100,000 face value has an initial price of the $96,618. So what you do is, I'm not exactly sure what the interest rate is that they are using, but you have to use some kind of interest rate. So I guess this is how you figure it out. The 100,000, when you put this in your calculator, the 100,000 will be the future value. The $96,618 and 36 cents is the present value. Your N is 1. Your payments per year is 1 because this is only a 1-year zero coupon bond. So from that, you can solve for your interest rate, and it will tell you what that interest rate is. So if you do that, so N is 1. The interest rate is what we're trying to find. Present value is the 96,618.36. Future value is 100,000. No payment. Payment per year 1. So when you do that and solve for the interest, you should come up with. There's that one. Oh, let me go back. You should come up with 3.5%. That's what it ends up to be. Hopefully you got that. If not, then back up a little bit and we'll try that again. So let's do another problem. This one is in the book. Suppose the following zero coupon bonds are trading at the prices shown below per $100 face value. Determine the corresponding yield to maturity. Yield to maturity is the interest rate. So in all of these, you're trying to find the interest rate. So the N is always whatever the number of years, because there's no interest payment, so you don't have to worry about different payments. So if it's a 3-year bond, the N is 3, the I is what you're trying to solve for. Present value is this $87.63. Payments are always 0 for a zero coupon bond. And then future value is $100 because that's the face value. Payments per year are 1. So you can do that with any of these, and you can figure out what the corresponding yield to maturity is for each of these. So if we did this yield to maturity, here's the answer for all of these. The first one was 3.5, and for 2 years, 4.0, 4.5, and 4.75 for years 2 through 4. So we can pause here, and we can try to do problem 3 if you would like to do that. In the zero coupon bonds, the risk-free interest rates with these, the Treasury bonds, for instance, are basically risk-free. So a default-free is the same as risk-free. So because a default-free zero coupon bond matures on a particular date, it is a risk-free return. So it's guaranteed that you will get that back. The law of one price guarantees the risk-free interest rate equals the yield to maturity. So on those Treasury bills, when we did the one that was a 3.5%, that is the risk-free rate. That risk-free rate is the same as the yield to maturity, and the market price should reflect that yield to maturity. The spot interest rates, the default free or for the zero coupon bonds, in Chapter 5 we introduced the yield curve, which plots the risk-free interest rate for different maturities. And these rates are the yields of risk-free zero coupon bonds. Now this becomes important as we get toward the end of the chapter, because these are risk-free, and then corporations have their own bonds, and when they have their own bonds, they are absolutely are not risk-free. And so then you look at the difference between the risk-free maturity, yield to maturity, and the actual yield to maturity for these corporate bonds. And so, but the yield curve is the zero coupon bond yield curve, or also the risk-free zero coupon bond. And so here is the yield curve for the zero coupon bond. And as you see, as the maturity gets longer and longer, then the yield gets higher and higher, because it is riskier, and we'll see this later, it is riskier when for longer term. So given the yield curve that was in that figure 6.2 that was on the previous slide, it's also in your book, what is the price of a 5-year risk-free zero coupon bond with a face value of $100? So basically what it is, let's go back, I'm going to go back a slide. 5-year risk-free zero coupon bond. So 5-year is right here where they have the dot on the upper right. It's a 5%. So all you are doing is you are trying to find the present value of that $100 in 5 years. So 5 years, the $100 is the future value, and we're trying to solve for the present value. Well, you already know the formula for that. I'm going to go to here. The formula for that present value is 100 divided by 1 plus the rate to the n power. And so 100 is the future value, 5% is the rate, and 5 is the number of years. So the present value of that, or the price of that bond right now, is $78.35. So we can compute the price of a zero coupon bond basically just by finding the present value. Present value using that present value formula that we used back in, I believe, chapter 3. So the price of a 5-year zero coupon bond is even lower than the price of the other because it's the same face amount, but it's a longer period of time. That makes sense. The longer period of time, the less the price of that bond is. So looking at this other problem, what's the price of a 3-year risk-free zero coupon bond with a face value of 900? So I don't have this worked out on the screen, but you can do this and give it a shot. And the answer, well, you can pause it here, put it in there, figure out the answer, and the answer is 788.67. So see if you can get that. Oops, sorry. All right, coupon bonds. So zero coupon bonds make absolutely no payments. Coupon bonds pay the face value maturity, but they also make interest payments periodically. And two types of U.S. Treasury coupon securities are Treasury notes, and these are normally 1 to 10 years, and Treasury bonds, which are more than 10 years. So we have the Treasury securities, the Treasury bills, and those were the zero coupon bonds. Those were the deep discount. And then these two, the Treasury notes and the Treasury bonds, are coupon bonds, but they are, I guess, classified by either notes or bonds, depending on the maturity date. So you have the three ones. This is on page 151 of your book. You have the bills that are the zero coupon bonds, the notes that are the coupon bonds for 2 to 10 years, and then the bonds are, which are coupon, they pay interest. Those are even longer maturity. And remember, these are risk-free because these are U.S. Treasury securities. These are risk-free bills or notes or bonds. So with a coupon bond, return on the bond comes from two things. One is the face value or the future value, difference between the purchase price and the future value, and it also is the interest. So you're going to buy the bond at different prices, and we'll talk about that later on. So to compute the yield to the maturity of a coupon bond, we need to know the coupon interest payments and when they are paid. Best thing to do with this, as you learned in, I believe, chapter 1, or I can't remember, maybe it was chapter 3, you really do need to do a timeline with these. So here is a problem. So we'll give this a shot. We'll work through this, and then you can pause it, and I believe we have some problems that we can work on from the book. All right, assume that's May 15, 2010. The U.S. Treasury has just issued securities with May 2015 maturity. So it's 5-year. $1,000 par value and a 2.2% coupon rate with semi-annual coupons. Since the original maturity is only 5 years, these would be called notes as opposed to bonds. So the first coupon payment will be paid on November 15, 2010 because it's a semi-annual, so every 6 months there's a payment. So what cash flows will you receive if you hold this note to maturity? All right, so if you draw your timeline, you are going to get 2.2% of the $1,000 every year. Well, you get half of it every 6 months. So let's see, you can read all this. The third button down, or bullet down, the phrase 2.2% coupon rate, semi-annual coupons, tells us that the note pays a total of 2.2% of its face value each year in 2 equal semi-annual installments. First one's paid November 15, 2010. When you do draw your timeline, here it is. You're going to have 10 payments because it's 5 years, and every 6 months you get a payment. The payment is $11, which is the $1,000 times the 2.2% interest divided by 2 because it's twice a year. And so you get $11 every 6 months, and then at the very end you're going to get the $11 plus you get the $1,000, which is the face value. All right, so basically it's just a package of cash flows. It's an annuity, if you think of it that way. It is kind of an annuity, but then there's also a future value with that. So there's a present value, there is a payment, and then there's future value. So keep that in mind when we're dealing with bonds or notes of these kinds. All right, so here's a different one. Assume it's January 15, 2010. U.S. Treasury has just issued securities January 15, 2019. So it looks like it's a 9-year maturity. $1,000 par value, 3% coupon rate, semi-annual. The original maturity is only 9 years. These are called notes. All right, so the first coupon payment will be paid July 15, 2010. It's 6 months. So what cash flows would you receive if you hold the note to maturity? So how much would you get paid every 6 months for this bond? It's a $1,000 bond, 3% for a year. So you're actually only getting 1.5% every 6 months. So you're getting $15 every 6 months, and at the very end, you're going to get $1,000 plus the $15 that is due at the very end. So if you want to pause now and go to problem 8, and you'll see that in that other recording. All right. One of the problems that you will be working on is to try to find the yield to maturity of a coupon bond. And so once you've done your cash flows on the timeline like you did in the previous section, that will help you determine what the time or what the yield to maturity is. Each one of these, well, on the left hand side of the screen, a negative P, that's the present value, and that's the amount that you're buying your bond for. The CPN are the coupon payments, or the periodic payments, and at the very end you have the coupon payments plus you have your future value, which is the same as the maturity value. And this formula, which is a big formula, what it's doing is there's 2 parts. You're trying to find the present value of an annuity, which are all your payments, plus you're trying to find the present value of that maturity, like $1,000 or whatever it is due in so many years. You can do this on your cool calculators way easier if you put all the parts in and put them in there correctly with the negatives in the right spot and the positives in the right spot. So I'll explain how to do that, and it will make it a whole lot easier. All right, there's a 5-year, $1,000 bond, 2.2% coupon rate, and the semi-annual coupons described in example 6.3 that we did before. If this bond is currently trading for a price of $963.11, what's the bond's yield to maturity? All right, so the $1,000 is the future value. The 2.2% is just, all we're using that for is to figure out what our interest payment is. Our interest payment is actually 1.1% of the $1,000 because it's semi-annually. This was what we did a while ago. So $11 every 6 months is our payment that we are going to receive. The $963.11 is our present value. So on your calculator, you'll put it in like this. N equals 10 because it's a 5-year bond, but you have semi-annual payments. And so you have 10 payments in total. I is what we're trying to find. Present value. This is what you're actually paying, so you put this in as a negative. Negative $963.11. The payment, you're receiving that. And so that is a positive $11 because every 6 months you get an $11 interest payment. The future value is the $1,000 that you will receive at the end. So you would have to also put that in there as a positive. The payments per year is 2. So to review that, N equal 10, I is what we're trying to find. Present value is a negative $963.11. Payment is a positive 11. Future value is a positive 1,000. Payments per year is 2. So if you solve for the I, if you put all that in there, solve for the I, you should get, on a good day, where's the answer? 3%. You should get 3%. So 3% is the annual, is 1.5% every 6 months. But your calculator, if you put it in there, payments per year, in there as 2 payments per year, you should get 3%. And hopefully you got that. So what you can do is, we'll do one more of these and then you can work out a problem. We'll work out problem 11. So one more of these, $1,000 bond, 2.2% rate, semi-annual. Maybe interest rates drop and the bond's yield to maturity decreases to 2%. Expressed as an APR semi-annual compounding. What's the price of the bond trading for now? All right, this one's a different problem. The 2.2% is only used for the amount of interest that you receive. So the interest is still $11. Payment's still $11. $1,000 is still a future value. The present value is what we're trying to find, because the interest rate, instead of 3%, that was the effective one that we just came up with, if the interest rates actually drop to 2%, the market rates, then we need to find out what the actual present value is. So how you'll put this into your calculator, N is 10, I is 2, present value is what you're trying to solve for. Payment is a positive 11, future value is a positive 1,000, and the payments per year is 2. So what you should end up with, after you put all that in there, and there it is, $1,009.47. And we can just keep doing these all day long because they're pretty much the same. Note that, oh, there it is with the calculator. Note with this, the bond's price has risen to $1,009.47 because the interest rate dropped, lowering the return from the investing in it from 1.5% to 1% per 6-month period, or 3% to 2% for a whole year. Interest rates dropped, so the lower return brings the bond yield into line with the lower competitive rates being offered. So we get into this a little bit later, but the lower the interest rate, the higher the bond price. I know it kind of seems weird, but just hang in there with me. Let's do one more of these. This is the 9-year. 9-year $1,000 note, 3% coupon rate, semi-annually coupons. If this bond is currently trading for a price of $1,038.32, what's the effective interest rate, or what's the yield to maturity? So put this into your calculator, and you should come up, put it all in there as we did before. I'll give you the answer. The present value is what you're trying to solve for. No, sorry, present value is $1,038.32. You're trying to solve for I, and I, here's the answer, but put it in there, pause it here, put it in there, and see if you come out with the same answer. Should be 2.52%. All right, so from this point, you can pause here. We will work together problems 8, no, yeah, maybe 11. All right, we said problem 8. So problems 9, 10, 11, and 12 on the other recording.